of how one would use these sort of classical item statistics to make decisions about what items to keep or what items not to keep. I'm not saying this is a great example or this is the right way to do it. It's a story. But one of the things that I will ask you to do in your individual homework data is to go through this process. Because if you have large problems in terms of your items, you will find them at this stage. Items, for instance, that have a negative correlation with the total score, that can't be good. Items that don't have variance, that's not good. So those sorts of problems will show up at this level of descriptive sort of bivariate statistics. So I have an example here that I pulled up. Example 3 is what I've called it. It's available on the course website. Right below this handout is a data file set, a zip folder, that has, I think this might be a new personal record, 4 different programs. So I don't care what you use to do this assignment on your data. I'll show you how to do it in Stata, R, SAS, and SPSS. If you got something else, then you're on your own. But I think that covers like the lion's share of what people use nowadays. So this is a publication from when I was a graduate student. I worked as a GRA with the Beach Center on Disability. It is a collection of researchers and advocates who are trying to make life easier and better for families of children with disabilities. So they do a whole lot of important work. And one of the things that they were tasked with when I joined their project was creating instruments with which to develop, with which to evaluate the extent to which parents were satisfied with the services that they were getting as one arm, and then also the extent to which families felt like they had a good quality of life in various different dimensions. So throughout the semester, I'll tell you some stories from both of those projects. It was a very formative experience in learning how to do this kind of stuff for real. So here's the paper if you're interested in reading it. It's study 2 that I'm showing you. So we have a set of item responses. They initially had a whole bunch of focus groups to figure out what the items should look like. They had one pilot with a whole bunch of items. The bad items were culled from that. Then they did another pilot after changing some of the response category choices. And then this is the second instance. So we're looking at 2 different subscales: the extent to which you feel like your child is supported by the people who are working with your child, and the extent to which you feel like your family is supported. So I'll show you what the items are in just a little bit. But the first step would be just to get descriptive statistics for the items. So I'm starting with Stata and R. So here are the item numbers in the data set. I'm using the summarize function in Stata to get means, variances, and so forth. And I'm using the function in Stata that's PW core. So Stata users, there's a core and there's a PW core. Core requires complete data. It does listwise deletion, whereas PW core does not. And so that's why I'm using this one, because not everybody answered every item. In R, I am doing the same thing, albeit in a roundabout kind of way. Rather than listing in the function in R what items I want to include, it's easier to create a data set that only has those items. So that's the first thing that I did. So I created a new object that is the concatenation of all of those item names. I then subset the example 3 data set with just those columns, and I created a new data set that's called child 11 because it's the child subscale and because I had 11 items. I'm using the psych package, which has a describe function, which gives out summary statistics, as well as the function core that I believe is from base R to get Pearson correlations, and here is part of the R output. So we're not looking at the content of the items, we're just looking at the numbers here. And I have the mean column highlighted because that is going to be my indicator of item difficulty. So to interpret what a mean of 4.4 is, I have to know how many choices there were. So 1 to 5 is my scale. So what do you think about this distribution of means? What does this tell me about the distribution of these item responses? You think they're normal? No. They can't be. They've got to be skewed which way? Everyone's doing the picture in their head.
Negative skewed.
Yeah, or you could just look at the skew column and see that they're all negative, yeah. There's a pile at the end of 4s and 5s, and very few responses on the lower end. So all the the choices for these 1 to 5 is how important is ... Everything's important, which we shouldn't be surprised by, because during the qualitative focus group portion, they listed all the things that families said that they thought were important. Well, they got it right. So this scale has 2 different answer choices. One is looking at importance and the other is looking at satisfaction. Given that satisfaction is probably a lot more variable, like you could be satisfied with some things and not others, we're looking at importance here. But I already know off the bat that most of these items are going to have ceiling effects. So even though there's 5 choices, a linear model predicting these answers is probably not going to work well, because it's going to go out of bounds on the top end, given where the data is focused. So everybody thinks everything is important. The correlation...
You've got 5s for medians across all of them.
Yeah, that can't be good, right? The middle value is the end of the scale. I don't know how to make that make sense in my head, but that's what it says. I took the correlation matrix and I put it in Excel, and I did conditional formatting, which is one of my favorite things to do. It just looks pretty, but it actually helps, patterns, I think, come out to you. So in terms of these items, do they look to you like they're measuring the same thing based on these correlations? Do you think?
What should we see if they are?
Well, at a minimum, they all should be correlated. So if there's an item that isn't related to the others, it can't possibly be measuring the same thing.
Oh, yeah, so we should see something closer to green everywhere.
Green is good.
Green is good.
Yes, green is good. And yeah, that's the other reason why I colored it this way. You can choose whichever colors you want, but green is a positive correlation and red is smaller. Like red means stop. These items aren't correlated.
Yeah, there's clusters of red in a lot of places.
Yeah, there's little clusters, and there's some certainly, like these 2 are a lot more related to item 15 for whatever reason, but at least they're correlated. So I know I've got something to work with. So if you get to this stage and your data and your items aren't correlated, game over. That's it. Because the whole job of the latent factor is to reproduce this pattern of correlations using factor loadings and intercepts, or using discriminations and difficulty in IRT land. If there's nothing in terms of the correlation to be reproduced, the factor has nothing to do. So no matter how many people you have, you can always look at a correlation matrix and a pile of means, and you can anticipate how well this is going to go. Some of these, like 4.85, that's getting close to being a constant. So I would be cautious about interpreting correlations with items that are functionally constants, because you got to have variance before you can have covariance. So some of those low relationships may be a range restriction problem. Even though these aren't binary, the range is still limited by what is possible for the scale. So I don't know if these are all measuring one thing, but it looks like they're measuring something in common, at least to some extent. Play ball. Here's another section for Stata using the alpha command to get Cronbach's alpha. And then I have the same thing down here in R. So Stata labels its output differently. It has item test correlation, and then it has item rest correlation. I have this one in bold because this is the one we want to pay attention to. This is our index of item discrimination. How related is each item response with the total omitting that item, so that you're not correlating an item with itself? So what do we think of the values in this column here? You see anything that gives you pause? Nothing terrible, nothing negative. Everything's probably significant. I don't care about p-values right now. I'm just looking at effect size. But this one's the lowest, it looks like. Item 15, yes. Here's what the items actually are, by the way. So, item 5, that's what it is. Help you gain skills or information to get what your child needs. That one is less related to the others. Have the skills to help your child succeed, provide services that meet your child's needs, speak up for your child's interests, let you know when your child does good things. I have 2 bolded here, and I want to see if you can guess why I did that. Not based on the stats, based on the content. Why do you think that I pulled those 2 items out for emphasis? The items are available when you need them and are honest even when they have bad news. The rest of the items I didn't read. For those of you who can't see as well, treat your child with dignity, build on your child's strengths, value your opinion, and keep your child safe. By the way, this one, keep your child safe, that's the one that was functionally a constant. Who's going to disagree with that? But what makes item 10 and 14 different, do you think?
Those are the ones that might not be applicable, like available when you need them, what if you've never needed them? How do you answer that?
Yep, that's one reason.
Never told you bad news, or?
Yeah, like that presupposes there is bad news to share, right? I want a not applicable button, damn it. Yeah, the same thing. That is, it is a good observation, but not where I was going. We have a comment from the Zoomers. Those two don't say your child. That's it. Every other item has child in it somewhere. These two are about how the provider relates to the parent. They're available to the parent when the parent needs them. They're honest with the parent, even if it's bad news. Now that you might ask the question, well then why are these on this scale? Do you know the answer to that? True story. EFA put them there. That's why. Because all of this stuff started with exploratory factor analysis to decide what the items were measuring, and the initial EFA after the first data collection put these two items there. And it wasn't until we started really looking at the content of the items in the context of these statistics as well as confirmatory factor analysis type stuff that it occurred to us like, hey, these go on the parent scale instead. So even though there's nothing wrong with them per se in terms of their inter-item correlation, the correlation of the item with the item rest correlation, for this reason it doesn't look like they belong. It's more of a validity issue. The last column here is another thing that folks pay attention to. It is labeled badly. It is labeled alpha. It is not alpha. It is the opposite. I know. This is why I have a job, people. Because the people who make the software don't necessarily make it user-friendly. This is alpha if deleted. Each of those values is what would your Cronbox alpha be if that item wasn't in the scale. So large values are bad because that means alpha would have gone up if you left that item out. So people will scroll down this list as a way to predict, which ones can I get rid of? Does the location of the items in the scale matter? No. Cronbox alpha has number of items and correlation. Doesn't have any item means in it. Location doesn't matter. All of these items are equal in that regard. Doesn't matter. So none of these look terrible in the sense that alpha would be much higher. But this is how people tend to select items to be included as they go through these sorts of statistics. So the alpha overall across these 11 items is 0.91, which is pretty good. So alpha would be lower than that if any of them were removed. So on the basis of the numbers, we could keep all 11. On the basis of what they mean and having it make sense, these two got to go. In our output, good luck. I found an article that helped me figure this out, and I think I linked to it in this handout somewhere. Raw alpha is alpha if deleted. Each of these packages gives you a standardized version or an unstandardized. Just use the unstandardized. I don't know what this is. This is some other reliability statistic, and I'm not sure what most of the others are either. But this table has alpha if deleted. And then there's another table that is r.drop. That is the item rest correlation. So, yeah, this is I found a tutorial online that gave me the definitions of these columns, so I linked to that. R.drop is the discrimination. So those values pretty much match across programs, although a little bit different. So then I took those two items out, looked at what was left in terms of the 9 items that all had the word your child in them, repeated the process, and found an alpha that is a little bit lower, so it was 0.91. Now it's 0.89 because I lost 2 items, because alpha is the number of items plus the correlation. but the rest of them seem to be reasonably okay. So we have the alpha if deleted. That doesn't indicate any of them would increase alpha if removed. We got the last column here for how correlated each item is with the total. These all seem reasonable. There's some variability. That one in particular is the lowest, but the people who knew about the content insisted that item need to be there based on it covering something that not the other items covered. So there's always like a what's the word I want? Trade-off, that's the word I want, between what do the stats say and then what is the construct. You can have an item that is different than the other items, but in a good way, like it covers an aspect of the construct that they don't cover, but because it covers something different, it's not as related. So you may decide to keep items that look bad because you want to make sure that you're covering all of the domain of your construct. So there's like a reliability, validity trade-off type of situation. All right, any questions so far? So the 9 then ended up being okay. Here's the corresponding stata code, item rest correlation, alpha if deleted, about the same answer for reliability, 0.9. So the end of that scale. Let's look at the other one. So I'm using SPSS and SAS for this one, just to show how one would do it in all the programs that people might use. In SPSS, there's a reliability command where you list out all of the variables. I don't believe SPSS allows missing data, if I remember correctly. At least at the point when I originally was looking at this, it didn't. Maybe a newer version does. So it may do list-wise deletion.
You have to pay money if you want it to deal with your missing data.
You do what?
You have to pay money for an add-on if you want it to deal with your missing
Yeah,
data.
I remember
Okay.
there being an MCAR thing in it.
Okay, so short of having extra money to address your missing data, it's going to do list-wise deletion. That's one of the nice things about using maximum likelihood is that you don't have to do that. Not everybody had to answer every item. You can still do your latent trait models. The assumption that you're making is either missing at random or missing completely at random based on your estimator. We'll talk about that later. So we have descriptives in SPSS to get the descriptive statistics, reliability, which gives us all the alpha stuff as well as Pearson correlations if you ask for them. In SAS, proc core does all of that. It spits out descriptives, correlations, and if you include the keyword alpha, it does that stuff too. I have added a thing to save the correlation matrix out as a SAS data set and then export it into Excel. And I have the exported files as well as my formatted versions in the download folder. So that's how I made the pretty color pictures, is outporting. That's a new word. Outporting or exputting. How's that? I'm going to exput it. Yeah, I'm just making words up at this point. So here are the other items. So this is the parent subscale, and it's all about how the care provider for the child with disabilities relates to the parent. So we have are available when you need them and are honest when they have bad news as the two items from before that got moved to this scale, and here's the rest of them. Use words that you understand, plan meetings, at times and places that are good, return your messages, keep appointments, protect your family's privacy, show respect for your family's values, listen without judging, dependable, pay attention, and friendly. So these are all desirable characteristics of a care provider. What do we think about this column of means? Same problem. This is highly skewed data. Everything's important. Some of these, by the way, don't even have all the response options. So the minimum on item 19 was 3. How important is it that they keep appointments? Everyone else, here's one that had a minimum of 2. The good news is that in latent trait models, this doesn't matter either. You can have some items that have 5 categories. This item would only have 3 categories, and that's fine too. Not a problem. Here's my correlations. It looks like item 20 is a bit sus. There's a lot of red in that one. What's item 20 about? Protect your family's privacy. That one is different than the others somehow. And so me, as the grad student in charge of the data, was like, let's delete it. And the people who wrote the items were like, absolutely not. Privacy is super important, and we need to have that in here for construct validity, so we're keeping it even though that item isn't as correlated. Okay, fair enough. trade-off time. Otherwise, we have a smattering of correlations ranging in size, some pockets of more or less. So we did find out that it is sufficiently unidimensional in factor analyses, but item 20 is less good across the board. These, what are we at, 14 items, something like that? Alpha is 0.92 for this. And then if you're using SAS, the labels are a little bit better, not much. They label it as alpha with deleted variable for the alpha column. So we have correlation with total, which is actually item rest, by the way. It's not the original total. So here are our item discriminations. Here is what alpha would be without that item. And I've highlighted the two that seem a little bit sus. So item 20, inter-item correlations are leading to this pattern. It's not as related to the total. It's still related at least to some extent, but it's not as strong. If I got rid of this item, alpha would go up a little bit relative to what it is with it. But they kept it for construct validity reasons. Our new items that we borrowed from the other scale, availability looks like it's hanging in there just fine. This one's a little bit lower. And that could be because not applicable, right? Maybe they haven't had bad news yet, so they don't know how to answer the question. Could be, who knows? Here is SPSS and SAS for dropping items. Here's what ended up happening. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 items. We ended up with 9 for the other scale, and so we decided we would want 9 for this one, just for symmetry. So we ended up getting rid of these 3 items. The reason for that is because we felt that the content was already covered. Plan meetings, return messages, and keep appointments, they're available when you need them. Or they're dependable. So these are much more specific ways of asking that question that we decided we could live without. So those left, 14 and 20 stayed. Repeat the process. Alpha is 0.88, so a little bit lower without those 3 items, but still within striking distance. Same pattern where 20 is a bit sus, but not completely terrible. And that's the end of the story. We did do confirmatory factor analysis to say whether or not these things are measuring 2 traits and to examine the extent of the correlation in the article after this, and it did work reasonably well. However, I did confirmatory factor analysis. Do you remember what kind of items that's for?
Continuous.
Continuous. Continuous and something else that starts with an N.
Normal distributed.
Normal. I'm going to go back to the summary statistics. Think these are normal? Nope. Think they're continuous? Nope. Why'd I do CFA?
So you didn't know how to do latent trace.
That's right. Because Lisa, the graduate student, was doing good just to get CFA right. I didn't know anything else past that. And the way that I was taught IRT was like it was a completely separate thing that had nothing to do with this. So in my defense, one of the things that we tried to do in this article, if I'm remembering which one it is correctly, is to use robust estimation. So in M+ and in Lavon, there is a robust version of maximum likelihood that adjusts the fit statistics and the standard errors for non-normality. And it had just came out with the capacity to include missing responses both. And I think we got it into this paper. Like it was during like the revision where it just came out. So this is yet another example of do as I say, not as I did. But I want to be honest with you because you all have papers in your life that you look back and you're like, yeah, that's not right. Or I know how to do it better now. It's unavoidable. The problem would be if we don't grow. So, true stories from the tales of scale development. And scale development articles almost always end up getting cited in someone's method section. So even though this scale is a very specific scale in terms of like who it's intended for, I note that I just looked in my Google Scholar and it's been cited almost 300 times. So these sorts of papers where you're describing the psychometric properties of a set of items and establishing dimensionality, giving reliability coefficients, validity coefficients, these things get cited. So I would encourage you to think along those lines. If you're working on scale development stuff for some purpose, you can have 2 papers come out of that. The scale development aspect, and then using what you found to go answer the research questions that drove you to make the scale in the first place. That can be 2 different pieces of literature.
And that's at least one citation?
That's at least 1 citation. Yep. Yep. More generally, I would say that that is a good strategy anytime that you're doing something that's methodologically complex, where you can't give all of the details in the primary paper. You can write a separate paper that expands, describes, and documents that methodological process that you then refer to as, oh, by the way, see that paper for what we did. Now here's what we found. So being planful about your publications as we go through this process, I think, is a good way to not necessarily have a least publishable unit, but to make sure that all of the appropriate documentation gets out there. So, anywho, thoughts or questions on any of this?
I have a status-specific question
Hit me.
about the alpha command.
The what?
you can-
Which one?
Alpha.
Alpha. Yes. Let me go back to that.
Because I have used that before. And you can add the standardization
Mhm.
option at the end.
Yes.
And I'm curious, because the way it's been explained to me is basically like if you've got items with different response options, that accounts for that. And you've been challenging a lot of things that people have been telling me, and so I
That's
just
a very
wanted
nice way to put it.
clarify.
Yeah, I think that in this case, so I would, to that I would say, what do you mean by same scale? Because if you look at what is possible for these items, let me get back to these, here we go. Like, they're on the same scale, right? 1 to 5, they have the same anchors, like from that, like, same scale. But if you think of it as in terms of the scale, like, what does a unit mean? Like, what's a standard deviation? They're on different scales.
No, I'm talking about like you've got a question that's 5 response options, and you've got a question that's 7.
Mm.
We've done alpha and just used the standardized option.
I think that that would probably make sense.
Okay.
I haven't considered that particular application of different types of, in putting the items together though, what do? Would you just compute a scale score, or would you do anything separate to address the 5 versus 7?
We would just use the alpha score that we would get because, like, I mean, we would do like the diagnostics that you were just kind of walking through in terms of like we would look at all of the options and whatnot.
Mhm.
But at the end, it would just be using the alpha score.
But-
Or
But in terms of like, what do you do with the item
Yes.
responses?
I think they would be standardized, like,
Standardize before combining?
yeah,
Okay, yeah, that's what I was hoping you would say.
yeah.
Yeah, because if you have an item that has 7 points and an item that has 5,
Oh, you can use the gen option,
Mhm.
and it creates it for you. So if you have the standardized option,
so like there's
that's why I couldn't answer it right away because it's under the hood kind of stuff. But
yeah, so like you
It
can
would
add
say
another,
that.
yeah, I have a note you can add standard, so if you have there's more options that will make a
yeah, so if
sum?
you do gen, which is generate, and then name the new variable, you've got your sum score.
Oh, okay,
Yeah.
that's really nice.
Yep.
Yeah, the more I learn about Stata, it's like, no, Stata was made for data analysts. Like, they think of these things like, well, you're going to do that next anyway, why don't I just do this for you? Yeah, that's good, because if you have a 7-point item and a 5-point item and you just add them together, the one that has more variance counts more. And so I don't think you want that. But the good news is you can have as many categories as you need in the latent trait models. It's fine. You just would have fewer thresholds for an item with fewer possibles. But good, I didn't know that. Yeah, very cool. I did put a link to the Stata documentation, so you can go online and see what all the fun options are, as well as to the psych package in R where I did this stuff. But all right. So this is exciting because that means next week we get to start latent trait models. Last year I drug this out for 2 more weeks, and I was determined not to have that happen again. So we are starting CFA on Tuesday. Very exciting. As a reminder, Monday is a holiday, so no office hours on Monday. I'm having them Tuesday after class instead. And next Thursday we will only be on Zoom because we're being kicked out of this room. Alrighty. Anything else before we call today? Cool. Then thank you for being here. Let's see, it's Thursday, which means have a good weekend. And let me know if you need anything. Bye, folks.